present you with Zineb the Posidonia study, and then the Thalassemia-Pavos study. And then I will conclude and give you some perspective about the topic. So we know that the complexity of marine ecosystem are very difficult to understand how it works, to effectively manage them, and to assess eventual modification. And one way which is widely used by ecologists is to simplify this complexity is the use of indicative species. And those organisms are basically very sensitive to environmental change and or specific stress. And that's why it may represent good indicators to assess eventual changes in the environment, especially when we don't have a huge amount of data about it. So we wanted to test the reliability of two indicative species, which are Posidonia oceanica and Oceanica and Thalassemia-Pavos, which for this one is supposed to be sensitive to human impact and especially to anchoring pressure in our case. And Thalassemia-Pavos, which is supposed to increase with temperature. Now the method we used on Lerins, we separated the Lerins Island into 6 groups with 10 stations for each one, separated by 200 meters, because it's a bit too much, and with transects at each station of 10 meters long and 3 meters depth to quantify the species that were in this quadrat of 30 square meters. And now let Zineb talk about the Posidonia case.
So, Lerins is a region which attracts a lot of tourists, and it increased a lot these past years. And with this development of tourism, the number of boats increased as well. So, because it increased, the number of boats increased, to have an idea about numbers, it passed from 600 boats in 2012 to 2,000 boats units per day in 2019. So this increase is not without consequences, or this pressure is not without consequences on the seafloor. And especially to Posidonia, because the action of the anchor can destroy the Posidonia meadow. So in order to mitigate this risk, a law was implemented in 2016 and to forbid this anchoring in 2 areas in Lerins. So to see whether Posidonia is a reliable indicator of anchoring pressure, we thought it would be interesting to compare areas where the pressure is high with areas where there is where it's forbidden to anchor, so areas where there is no high pressure of anchoring. So our new hypothesis is that there is no significant difference in Posidonia coverage between the 2 zones, and the alternative one is Posidonia is less abundant in areas where it has been affected by boat anchoring. So where anchoring is forbidden, it's situated in the northwest of Sainte Marguerite and southeast of Saint Honorat, and where anchoring is authorized, where there is a high pressure of boats, it's in the south of Sainte Marguerite. Data was collected in 2018, snorkeling along the transect, and we classified Posidonia coverage from degree of fragmentation, from 1 to 5, from where there is no Posidonia to homogeneous coverage. To do so, we used the Student test. And for result, as you can see here, Posidonia shows a similar degree of fragmentation in no anchoring area and anchoring area, with highly fragmented coverage. And we found a p-value higher than 0.05. That means that Posidonia is equally abundant in the 2 areas, and our null hypothesis is accepted. That means that Posidonia is not a reliable indicator of anchoring pressure. But we have also to add that to understand why the action of the anchor, we didn't see the action of the anchor in this case by the small size of boats in Lerins, but also the short time where they do like the pressure. It's only in the summertime, maybe. That's why we can see a huge impact of boats in this case. But to confirm or to view our results, we compared them with other authors, and in all the three cases, and they saw that they say that Posidonia is a good indicator. So, but in all their cases, there is a huge impact of boats in their case. They use only big boats. So that means, actually, that confirms our what we found, and that we can conclude that Posidonia is not sensitive to this particular stress, which is anchoring pressure. And I let you see with Anesca.
For the next part of the study, we compared the reliability, or we looked at the reliability of Thalassomer pavo as an indicative species of, or an indicator of rising water temperatures. Thalassomer pavo is a species of wrasse that prefers areas where the water temperature is higher. Studies in the past have shown that Thalassomer pavo's population increases as temperature increases throughout the years. It's especially in the Mediterranean that these studies have been conducted. This is a curve to show the population growth of Thalassomer pavo throughout 2013 to 2018. We just took the sums of the around the Lerins Islands for each year because we don't know about the migration patterns of Thalassomer pavo, so it was easier to just take the whole population. We then took data that we collected from the Hotter team that will conduct their presentation after us. They supplied the temperature for around the Lerins Islands for the last few years. In their study, they found a rise in population, a rise in temperature throughout these years, and we then tried to see a correlation between the rising population and the water, or the water temperature around the Lerins Islands. There is no correlation from, or our null hypothesis is that there is no correlation between these two. And on R, we proved that because it has a p-value of 0.5, means there is no correlation. And our coefficient of correlation, we proved that there is no correlation because our coefficient of correlation is closer to 0 than to -1. Naturally, we know that there is a change in temperature won't directly affect the population of Thalassomer pavo. So we compared also the population growth of Thalassomer pavo to the population growth of two other wrasse species, Chorus julis and Symphodus riosali. These two fish these two wrasses are found in areas very similar to Thalassomer pavo. They prefer rocky bottoms and eelgrass, and they're found at similar depth. So we compared their population growth around the Lerins Islands to the population growth of Thalassomer pavo. And we saw similarities, which we tested on R, and found that there is no significant difference between the population growth of Thalassomer pavo and the population growth of these two wrasse species. So in conclusion, or for the Thalassomer pavo study, if these two species of wrasse grow at the same rate as Thalassomer pavo, it means that there are other environmental factors that influence the growth of Thalassomer pavo. Therefore, Thalassomer pavo cannot really be an indicator of water temperature specifically, or at least not around the Lerins Islands.
So to conclude on the whole study, on the reliability of those species, we can say that we can't quantify or measure the impact of anchoring pressure using Posidonia oceanica. And as Anesca said, that there is no correlation between temperature and Thalassomer growth temperature. And of course, we're not questioning the reliability of of those species, because there are literature that has proven that. But in Lerins Island, we can't conclude anything about environmental change and anchoring pressure. And this contradiction could be explained by several reasons. The human error, because we're not professional and we not collected the data properly, and also the time span may not be enough to assess changes in those 5 years. And also the seasonality, maybe it does this, the fact that we are collecting data in summer may not represent the population of those species. So with our exploitation of the data, we have validated the non-reliability of these indicative species in Lerins Island. So thank you for your attention.